In this session, we'll go over organic chemistry, and our focus will be on dehydration and hydration of alkenes. So let's get into it. We'll start with dehydration. Alright, so let's begin with dehydration. So just like the name itself suggests, dehydration. To dehydrate something, you're simply removing water. So we are removing the water, which is just H2O. So when you're talking about hydration of alcohols, you're simply changing alcohols to an alkene. So dehydration of alcohols so you're simply changing an alcohol into an alkene. So in short, you're forming a double bond. We know that an alcohol could be something of this nature, which has an OH. Now you're forming a double bond at some point, so you're changing this to something of this kind. Maybe a double bond could be here, or maybe it could be here, or it could be here, depending on the stable carbocation which you're going to form in the process. Okay, so let's have an example. Let's say we have this question. So we have this compound, then so this compound we have, which is an alcohol, it is undergoing dehydration by using concentrated sulfuric acid, which is H2SO4. So what will be the product we are going to form here after dehydration takes place? So if this is the question we have, we're going to say step 1, so our step 1 will first be protonating this OH, which is an hydroxyl, because OH, which is an hydroxyl, is a bad leaving group. It can't live on its own, so we need first to protonate it so that we form water. Then that water will be a good leaving group. It will be able to live. So our step 1 will be protonating this OH. So to protonate it, we can use this same concentrated sulfuric acid which we have. So we have sulfuric acid. We'll write it in this manner. Okay, let's write it in this manner, like H, starting with H, because it's the one we are interested in. So it is still sulfuric acid. So we have lone pairs on oxygen there. These lone pairs will grab a hydrogen there. Then the bond between hydrogen and oxygen is going to break, taking the electrons to oxygen. So basically what you're going to form will be something like this. Now it will be attached to water. So we're going to form something of this nature. Okay, attached to now this water. Now this water is a good leaving group, so it can leave. So the bond will break, taking the electrons to oxygen. So our step 2 will now be forming the carbocation there. So this water is going to leave. So this is what we have. Initially this is what we had, like this. So this water is going to leave, forming a carbocation. So we'll form a carbocation at this point. Now we can see that this carbocation you formed is formed from a primary carbon. So this is a primary carbocation. It is a primary carbocation, but a primary carbocation is not stable. So we need to transform this carbocation into a stable carbocation, meaning that we need to perform what is known as a methanide shift. So this methyl can shift to this point so that our carbocation can now be at this point. So we'll do a methanide shift. So let me go to the next page. Okay, so this will be our step 3. Our step 3. So from this, what we had, we'll do what is known as a methanide shift. Methanide shift. So methanide shift, you're just shifting the methyl. So it will move from that point. Then the methyl group will be there, meaning that the carbocation will now shift to this point. So in this case, we formed a tertiary carbocation, which is more stable than a primary carbocation. So after we do this methanide shift, we can now deprotonate one hydrogen, okay, so that we can form the double bond. So this will be our step 4. So our step 4, from this compound we have with a carbocation there, remember at this point we have a hydrogen there and another hydrogen, okay, but we are just interested in one hydrogen, so we can protonate one hydrogen by using a base. Mind you, we had a certain group which had left, which was a base, after we had formed after we had grabbed the hydrogen from this sulfuric acid. So the base was this one, which is OSO 3H. So we can use this base to deprotonate that hydrogen. So this is the base we have, OSO 3H. So it has a negative there. It can grab this hydrogen. After it grabs this hydrogen, this bond between hydrogen and this carbon will break, forming a double bond there. So this can break, forming a double bond there. So basically what you're going to form is this compound. So we're going to have a double bond there, then a methyl group, like that. So we have formed the alkene, and we can name it. Okay, so the double bond is at carbon number 1, 2. So that's where the double bond is. Then we can count the number of carbons, 1, 2, 3, 4. So this is but, because the double bond is at carbon number 2, so we'll call it but 2 in. So we formed this alkene. So we have performed what is known as dehydration of alcohols. We have formed an alkene from an alcohol. But when you're talking about hydration, it is just the opposite. With hydration, we'll start from the alkene, then we form an alcohol. So we can have something like this. Okay, let me go to the next page. Or let me erase this. So now let's do hydration. Hydration of alkenes. Okay, so with hydration of alkenes, you are simply forming an alcohol from an alkene. So we are adding water to an alkene. When we add water to an alkene, we are going to change an alkene into an alcohol. So this is what dehydration simply means. So let's have an example. Let's say we have this compound. This was a question from a tutorial sheet. So we have this compound. Then this compound is undergoing hydration using sulfuric acid in the presence of water. So if you check the reagents we are using, for dehydration we are using concentrated sulfuric acid, but for hydration we are using dilute sulfuric acid. We are using sulfuric acid which has been dissolved in water. So if we have this, the first step which we are going to perform will be breaking the double bond there. So let's have step 1 here. So this is what we have. So we are simply forming a product this side. Okay, so this is what we have. With a bond there. So the first step, we can use this water and grab the hydrogen from water. So we can use this same water which we have. So this double bond can grab an hydrogen from water, then this bond will break, taking the electrons to oxygen, because oxygen is more electronegative as compared to this hydrogen. So what we are going to form in the first step will be a carbocation. So in this double bond break, if we put the hydrogen which has been grabbed at this point, meaning that the carbocation will be at this point. So we are going to have this structure. So we can start with a hydrogen there, then we'll have something like this. So there we can have our carbocation, then we have the compound, which was this compound. Okay, so this will be our step one. We have just protonated this compound. We have grabbed this double bond has grabbed the hydrogen, then forming a carbocation there. Then our step two now will be step two, this carbocation here can attract oxygen. So we can have a carbocation like this. This carbocation can attract this oxygen. Of course, we can use water again at this point. So this water has lone pairs. So these lone pairs will attack this carbocation. Then what we are going to form will be something of this kind. So we'll form this compound, hydrogen there. Okay, so we have this. So this is bonded to 3 bonds. Okay, so we have this, then we had an hydrogen here. So our carbocation was at this point, meaning that we'll have our water bonded at this point. So we'll have our water here. Okay, so we have this, which is our compound. Then when we form an alcohol from this compound, actually this reaction will yield two products. One will be an alcohol which is going to be formed from this carbocation, which is just a primary alcohol. Then the other one is also an alcohol which is going to be formed from a more stable carbocation, which is the carbocation at this point. Okay, so you can just get rid of this. So what we had is this, or let me use the same. Okay, I'll use a different color here. Okay, so from our step 2, we had this hydrogen there with a carbocation at that point. Then this was bonded to three things. Okay. Then we formed this when we use water here, the lone pairs on water attack this carbocation. Then we had to form this compound here bonded to water. Okay, so it's bonded to water like that. Then this is bonded to three different things. Okay, so this is what we had. Okay, so now we can deprotonate this water by just removing one hydrogen. So our step 3 will be deprotonating this. So actually we can even form another carbocation here by just performing what is called anhydride shift. Okay, so we can do this. We can just do this from this point. We can form another carbocation. So it's bonded to these three things. The carbocation was there. Then this side we just had an hydrogen. So we can actually shift this carbocation to this stable carbon, which is bonded to four different things. So we can shift this carbocation to come at this point so that we form even a more stable carbocation as compared to this. So we can shift this methyl group to this point. Okay, so we can perform a methanide shift here. By shifting this methyl group to come there, so we'll have hydrogen there. Then a methyl group will shift to this point, meaning that we'll remain with this compound. So a carbocation will come at this point. So this is more stable as compared to this structure. But from this one, we'll form an alcohol which is not even stable because you're forming it from a carbocation which is a primary carbocation. But this one, we are going to form a stable alcohol because we are forming it from a carbocation which is a tertiary. Yeah. So this is what we have. So from this one, we can form an alcohol. We can just deprotonate this. Okay, let me use a different ink. So we can just deprotonate this by using a certain base, or we can use the same one, this base. Okay, so this one has lone pairs, so we can deprotonate this. This is just the base we formed from the compound, which is sulfuric acid. So what I've just done is removing the hydrogen from this sulfuric acid. Okay. So what I've just done is removing the hydrogen from this sulfuric acid like that. I've just removed this hydrogen, so this is the base I've used there. So it can be used to deprotonate this, then we can form an alcohol, which will be a primary alcohol. So it will be of this kind. We have hydrogen this side, so the alcohol will be formed at this point. Then of course with this, but this is not a stable alcohol. No wonder we had to perform a Maillard shift so that we can get this carbocation. Okay, so now we can use the second one. So this forms unstable. This forms unstable alcohol. Okay, so we go for this second one. So we have a hydrogen there, a methyl there, then the carbocation is here. So we can use water here. So we can say this water, since it has lone pairs of electrons, it can attack this carbocation. When this carbocation gets attacked, so we're going to form this compound, hydrogen, methyl there, then we're going to form an O attached to H there. Let me write it like this. So you can have oxygen there attached to hydrogen, and another hydrogen, which is just water attached. Then with these two methyl group we had from the actual compound. So after we have that, we can now deprotonate the hydrogen. We'll deprotonate this compound by removing the hydrogen. So we can have this. So this will be our step 3. So from this hydrogen bonded to a methyl there, with this O bonded to 2H. So remove one hydrogen by just deprotonating this compound. We can use the same base we used, OSO3H. So this one has a lone pair of electrons, so it can grab the hydrogen at that point. When it grabs, mind you, this oxygen is positively charged because oxygen is bonded to 3 different things. So it bonded to this carbon and 2 hydrogen, so this is positively charged. So we are going to grab the hydrogen there, then the bond will break. So when this bond breaks, it will take the electrons back to oxygen, hence neutralizing this positive charge on oxygen. So this is basically what happens. Then after this oxygen is neutralized, so the hydrogen there is gone to this compound, so it will form a bond. Then this compound will be deprotonated. So what we are going to have is this. So this will be the product. So we'll have a hydrogen, then bonded to a methyl, then we'll have this OH there. Okay, let me just write it, say this. Okay, so O, okay, we have this bond there, so our O H will be there, then this is bonded to this to methyl. So we have actually formed an alcohol from the reaction we were given. So let's just name this alcohol we formed. So this alcohol, we can count the number of carbons we have. We have 1, 2, 3, and 4. So at carbon number 2 there is a methyl, carbon number 3 there is an alcohol. But when naming this compound, we start from where there is a functional group. So we need to give the smallest number to the functional group. So we'll count from 1, 2, 3, 4. So at carbon number 2, that's where we have an alcohol, and this is but. So at carbon number 2 we have a methyl. At carbon number 3 we have a methyl. So we're going to say 2, 3. Because we have 2 methyl, we are going to call it dimethyl. Then this is a but because it has 4 carbon. Then at carbon number 2, that's where we have an alcohol, so it will be 2, 3 dimethyl. Then we can say 2 butano, or this sometimes it can also be written as 2, 3 dimethyl. Then we say butane 2 O. So naming it like this or naming it in this manner, it is just one and the same thing. Okay, so this is where we end with hydration and also dehydration of alcohols and hydration of alkenes. So this is where we end. Don't forget to like, share, and also subscribe.